Okay, so we've got the calculator all set up, and we've got example 1 that we're going to do, and we're going to enter in list 1, we're going to enter the numbers 1, 2, 3, 4, 5. You just hit the number 1 and press enter, and then 2 and hit enter, 3, 4, 5. And then we're going to go over to list 2. You just press your right arrow key to get to list 2. And once you're at the top of list 2, we want to enter 5.3, 4.5, 9.1, 17.5, and 18. And I messed up in my list 1, which I'm sure you see. I left out my 4. So I'll just go back and fix it. Now, what you probably will notice here is that 1, 2, 3, 4, 5, the numbers are going up. And except for the fact that 4.5 is smaller than 5.3, most of these numbers are also going up, which means that we're expecting to see a positive correlation, okay? Since as these go down the row, these follow the same pattern, okay? As X gets larger, Y also got larger. And that means the correlation is likely to be positive. So what we want to know is we want to make a scatter plot, and then we're going to find R. So to make the scatter plot, we press the second and the Y equals. Plot 1 is already chosen for you, so you just hit enter. There's no need to use more than 1. Press enter again to turn it on. Then you have to use your down arrow key. And when you down arrow, the very first plot that's highlighted is the scatter plot. It's basically just a plot of the points.
I'm sorry, how did you get to that screen? Or where you put in the...
You go to second Y equals to begin with. Okay? Then you hit enter. And that takes you to plot 1. And then you press enter while the cursor's flashing on. Then down arrow. And the plot we want is the very first one, and it's already highlighted on this, so we don't have to change it. And then we go down again, and the X values are in list 1. If it didn't say list 1, then we would press the second key and the number 1 key. Okay. It's being ugly. And then same thing for list 2. If it didn't already say list 2, then we would press the second key and the number 2 key. If it makes a letter when you do it, if you look really carefully at your cursor there, when it sits on that list, it's got a little A in it, and it's going to make alphabets. If you want it not to make alphabets, just press your green key and it'll make the alphabet part go away. And then if you wanted list 2, then you do second and 2. So basically, you can just leave that set up. If all you ever use is list 1 and list 2, you can just leave that set up. That's fine. You don't ever have to change it unless you're making a different kind of graph. So then now that we've got the data and we've turned the scatter plot on, The easiest way to get the calculator to make the graph is just to let it set the window. And the way you let it set the window is you press the zoom key. Okay? That's the blue key in the middle across the top. Press the zoom key, and then if you'll scroll down, and not go too far like I did. You want to go down to number 9. It says zoom stack. So you can just hit zoom and the number 9 key, but I wanted to show you why you would hit zoom and 9. Because 9 is the stat option. It makes the graph window fit your scatter plot. So all you have to do at that point is hit enter with the number 9 key lit up, and there's what we get. Okay? Okay, if you got an error, I need to see your calculator, because there's lots of reasons it could give you an error. Let me watch you do it. Press your zoom key. Hang on, I'll do your step. No. It's not you. How long have you had it?
Just since the first week. Classes.
I'll take that sucker back.
Believe everything we get for.
Did you rent it or did you buy it? Go back and tell them it's giving you another error message. Your picture said it ain't you. Okay? Because it's, I don't know.
He doesn't understand it. I just have to take the battery out of the frozen.
Well, unfortunately, I got to leave it out for a while. That's the part. Let me try one more time.
completely reset everything. So put your data back in, and then we'll try again. Now, yours at least gives me an option, so.
That's crazy.
Hopefully that was it.
I like that one better, so.
Okay, first your Zoom key. It was already heard your block.
Are you serious?
Number 9. There you go. I reset the whole memory. I don't know what was wrong with it.
When did y'all-
Okay, but that fixed it. It should fit, but if it keeps doing it, I would. Go over there and go, like, if you said there's something wrong with this calculator, it's defective. No, they're not, especially with the bookstore. Is everybody else doing okay with it? Did you get the graph?
It's really crazy.
Okay, now it might be helpful to draw a sketch of what you see, and this is what I mean by sketch. I don't mean to haul out a piece of graph paper and get a ruler. This is your y-axis, this is your x-axis. That's just to help keep you straight. And notice that the way the points seem to go is it's here, then it went down a little, then it went back up, went up some more, and then it kind of went up and over. So that looks enough like what I see on my calculator screen that I can tell that there's what I would call a positive correlation. Okay? Positive correlation means that as you go out the x-axis, which means x is getting bigger, then the y values tend to climb. And that means your y is getting bigger. So these are positively related. And it's also because if you were to try to draw a line through these, it would have a positive slope. Okay? It would go uphill. That's what a positive slope means. Now, if we calculate R, we're just going to go back to the stat button. We're going to go over to the middle to calculate. And then go down to where it says number 4, LINREG, which is linear regression. And we're going to press enter. And if the only list you ever use are list 1 and list 2, then all you have to do here is hit enter. Now, I bet Renee doesn't see R and R squared.
I don't know either.
It's because I always said remember. We'll put it back.
I'm gonna read this.
I think we should just get rid of the square to use.
Yeah.
Word.
And then,
Okay.
I had to hit enter. Okay, yeah, I had to hit enter. That's so awesome. Oh, wait.
There you go.
Now, your first window looked a little different from mine, but if you'll just go down to where it says calculate and then hit enter on that window, you're good to go. So this tells us that our correlation coefficient, which is R, it says find R, the correlation is 0.93. Now the way that works is, yes,
Why and
Mhm.
it says negative 0.64.
That's okay. That won't matter. We're not even worried about what those are, okay? Not for this class. Is your R the same as mine? Okay. Notice that it's positive. No, the R's not, then check your numbers. Go back and hit your stat button and look in list 1 and list 2 and make sure you didn't misenter one of the numbers. Because that can cause it too. It's really easy.
No, I didn't miss anything.
Let me have a look at it.
I'm getting something slightly different as well.
Okay, let me come back and look at your sheet. I may have listened to the numbers now. Let me check mine. I may have misentered one of mine. 5.3, 4.5. Nah, I did. It's mine that's wrong, not yours. This thing leaves out the decimals sometimes. Okay, so back to stat, over to calc, down to number 4. Does everybody match me now? Okay.
Not really.
Yeah, this one's too. Yeah, yours is too.
There it goes.
Yeah.
It wouldn't load my instructions. It just kept saying about a date, so
So what is what?
I am trying to figure out R. And I'm just that right there.
I guess.
You over to calc. Right arrow, and then down to number 4. Now, your one does not really look exactly the same, but if it says your X list is list 1, your Y list is list 2, and this should always be blank. And then you don't care about the other part. Actually, once you get there, just arrow straight down, calculate.
But I figured out of it and had to go make Q.
Yeah, hit enter. Let's, there you go. Okay.
No.
All right. Okay, now, by way of explanation about what is that R thing. R is between -1 and +1. It's never less than -1. It's never more than +1. Okay? In between -1 and +1 is a 0. If R is close to +1, that means your correlation is strong and it's positive. If R is close to -1, that means your correlation is strong, but it's negative. And we're going to see what that means when we do example 2. If R is close to 0, that means there's very little correlation or none. And when we do these examples, you're going to see every one of those happen. So the one we just looked at, as X increased, Y increased, we knew it was going to be positive, and it turned out to be strongly positive because or 0.93 is close to positive 1. Now, when you've got your notes made, what I want you to do is I want you to go back to your stat button. Don't change anything else. Just go back to your stat button and press enter to edit your data. And notice that in example 2, X gets bigger and bigger, Y starts out big and gets smaller and smaller, okay? So as X gets bigger, 1, 2, 3, 4, 5, Y got smaller. It went the other way. They went opposite directions. So what that means is that the correlation we're going to see is probably going to be negative. You can think of it this way. If X gets bigger, Y gets bigger, they both point the same direction. Or if they both point even the other direction. As long as they're pointing the same direction, that's a strong positive correlation. The strength of that relationship is measured by R. This one, they're not going in the same direction. They're going opposite directions, which means you have a negative correlation. So we're going to change those numbers, and the first number is going to be 19.0, and it'll actually leave off the 0.0, and then 11.2, and then 10, and then 6.2, and then 7.0. So the numbers got smaller and smaller. Now the only thing we're going to do at this point is we're going to hit the zoom key and the number 9 key again to do that zoom stat. What do you notice about the way the points fall on the screen? Which way are they traveling, uphill or downhill? Downhill. That's a negative relationship. Our scatter plot looks like this. So there's X, there's Y. First point's way up high at the very beginning, but then it drops down a lot. Then it drops down just a little bit more. Then it drops down again quite a bit. Then it actually comes up a little bit, but even though it actually came up a little bit, notice that still they're traveling downhill. And they don't quite line up, but they come fairly close to being in a linear pattern. So what we're going to do is we're going to calculate R again. So you hit your stat button, and you go over to calc, and you scroll down to number 4, and hit enter like we did before. And notice this time it tells us that R is negative 0.90. You can always round R to 2 decimal places.
It's gonna be like that same screen I had before. Okay, scroll all the way down. Now where it says calculate, hit enter. Okay? Everybody else okay?
What are these other results that we get in the mean, like in this screen? You've got it now?
Mm-hmm.
Like A, B, R squared?
That is actually the slope and the y-intercept of a line that would best fit through this. Okay? And if you'll notice, A is where the slope would be, if you remember that from algebra at all. And since A is negative, that tells you that your line is going to have a negative slope. So A and R are always gonna have the same sign. They're both gonna be positive or both gonna be negative. Okay? But we don't worry about fitting the line, we just look at whether or not there's a relationship. Okay? So, would you agree with me that negative 0.9 is pretty close to negative 1? Okay, and we said that when R is close to negative 1, there's a strong relationship, but it's negative. And this relationship is negative as X increases, Y decreases. Okay? Okay? So now we'll look at example 3. And for example 3, we're going to have to change the date a little bit. So we're going to go back and hit the Stat button one more time. And choose Edit by hitting Enter while it's on Edit. Go over to List 1. And this time, X goes up to 7. So we've got, 1, 2, 3, 4, 5, 6, 7. So just add 6 and 7 to your first list. And since the list we're typing in is longer than the one that's there, we can just type over the top of those numbers. So I went to the top of list 2 where it says 19 from this example. For this one, for our new example, it's going to be 12. And then 10. And then 13. And then 12. And then 11. And 11 again. And then 12. Now I want you to look at those numbers. What's happening as you go down list 1? What's happening to the X's? Are they going up or down? Yeah, no, the X is only going one way. X is going up. Yeah. Now Y, yes, you are exactly right. It's going every which way. It starts out at 12, then it drops to 10, then it goes back up to 13, then it goes back to 12, and it stays at 12. Then it drops down to 11 for a couple, and then it goes back to 12. So I don't see, it's not increasing, it's not decreasing, it's just kind of all over the place, right? Okay. Now that we've got the data in there, I want you to hit Stat, because we're going to calculate R first, so you'll be able to connect what you're going to see. Calculate R, so we're going to hit Stat and go over to Calculate. Go down and choose number 4. If you've got the TI 84, you've got one of the newer ones, then you're going to come up with a screen that says X list, Y list, frequency, equation. Just go all the way to the bottom of that screen where it says Calculate and hit Enter. Oh,
So,
you accidentally didn't enter, just copy that one. Okay. Yeah. When you go to the calculator, don't hit it, and calculate and down to number 4. What does it say R is? 0.
that's what it looks like.
Okay. So this one is already telling us R is equal to 0. Very little or no relationship. Now hit Zoom. Zoom. And go down to number 9 or press the number 9 key. Is this what you see? Is there a relationship? Or is that just paint splatters? It's just paint splatters. I mean, it looks like when it first starts raining, it looks like there's just a pattern of raindrops on the sidewalk. That's really all it is. So the reason R is equal to 0 is because as X increases, Y doesn't care. It says, X, do your own thing. And it just does whatever it wants to. Okay? So this is no relationship. There's no parallel lines like I did on these. I can't draw parallel lines on this one that will kind of close up those points in a cage. And that's because there's no pattern being formed. No consistent pattern. It changes all the time. Now, our one last problem is we're going to do example 4. So what we're going to do is we're going to go back to stat one more time, hit enter one more time, and in list 2 we're going to change the Y values to 7, then 17, then 23, then 25, and then 23 again. Good grief, this thing's being hateful. And then 17. And then 7. And I'm going to make sure that I didn't mess any of these up because it's picking up so many different numbers. Okay. Now, before we calculate R, we look at the scatter plot. What's happening to Y? X is still increasing, okay? What's happening to Y? Bigger, 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 smaller, smaller, smaller. Okay? So, do you think there's going to be a linear relationship? No. R's probably going to be close to 0 again. If not 0, let's see. So we're going to hit stat, press your right arrow key to go over to calc, choose number 4, and if you've got the TI-84, you're going to down arrow until you get to the bottom of the screen where it says calculate. If you've got the 83, it's going to look like this, and you just hit enter. And it says R is equal to 0. So that tells us there's not a linear pattern. And the reason there's not, if we hit the zoom button and go down and choose zoom stat or press number 9, does that fit a line? No. Is there not any pattern at all?
There's a pattern, but
It's not
Linear.
linear. That's right. There is a pattern here. In fact, if you've had some algebra, you realize that that's what we call a parabola. Okay? It's definitely a pattern. It's making the McDonald's arch. But it's not linear. It is not a linear pattern. It's got a curve to it. Okay? So R equals 0 doesn't mean there's no relationship. Although in this case, there wasn't. R equals 0 in this case just means there's no linear relationship. Because there's definitely a relationship, it just isn't linear. It's what we see. It's kind of like that. So yes, there's a relationship of some kind, but it isn't linear. Now basically that's all there is to correlation and regression. Correlation says, is there a relationship between two variables? Regression is basically the process of calculating R, because R is called the correlation coefficient. And pretty much that's it for that one. Does anybody have any questions before we go on?
So, how do we submit this homework? I mean, do you want us to sketch it and then do that, or?
You can sketch it. If you're using the one on the computer, there's actually a way to take a screenshot of the calculator and you can paste it in, but it's not worth the aggravation to do it. Just,
I can take a picture of my calculator and post it that way. But that would be a lot of,
yeah,
a lot of
that,
pictures for you to go through.
well, and it's probably better, really, this is more for you. Just be sure that you understand the ideas. You can sketch it and, you know, you can do it on paper and take a picture and post it or whatever you want to do. Okay?
For the test,
Mhm.
if people be allowed to have this, test step walkthrough,
I'll let you have it on this test, but not the final. Okay? Because by the time you got into the final, you probably will have practiced with these. And as a matter of fact, I can probably give you a cheat sheet for the final. I'll see if I can put one together for you. Okay, now the only thing we have left to look at are what are called characteristics of data sets. And we're going to be doing some number calculation, but we're not going to do any of this with formulas and do it by hand. Everything that we do, we're going to do, again, on the calculator. So you're going to remember where that stat button is because you're going to be using it. Okay? So what we want to do is we want to talk about the definitions of some of these words. In the beginning of talking about statistics, when you're trying to determine characteristics of sets of numbers, what do you think of when I tell you to calculate your average test rate? What do you do? Yeah, you add up your test scores and divide by how many tests you took. Okay, the actual technical word for that is mean. That average is the mean. That's the appropriate word. Mm-hmm.
how do you get out of this screen?
Second and, press second and mode.
It won't let me. I keep pressing that. It won't let me in.
Oh, you can just
Y'all know, I'm like, you know.
okay. No, it's okay. No, you're okay. Okay, so everybody knows what average is, right? The statistics word for average is the mean. Now there's actually two other statistical words that mean average, but in order to keep you from being confused about that, what we call those is measures of center. So the other two measures of center are called the median and the mode. The median is the value that is literally in the middle, but there is a little restriction there. It's in the middle when the values are sorted, usually in ascending order. Okay? Now, if you have an even number of numbers, then your median is going to be midway between the two numbers in the middle. Your mode is the number that appears the most often. You can have no mode because none of your numbers appear more than once, or you can have more than one mode. But if you have more than probably 2 modes or 3 modes in a really big set of data, then the mode probably doesn't tell you much because it has so many different possible values. Now, to get the first example, we're going to look at some data, and what this data is, this is the prices in dollars for a sample of room air conditioners. So here we've got, it's all the same kind of air conditioner, all the same size. It's 10,000 BTUs per hour. And the price of the first one is $500. The second one was $840. The third one was $470. The fourth one was $480. The fifth one was $420. And the sixth and seventh ones were both $440. Now, if you have your air conditioner go out on you, you're going to have to go buy one. And you have this information. When you go to the store to buy your air conditioner, about how much money should you be expecting to spend? Okay, 500, 470. Do you expect to spend $840?
No.
So you really expect values more like in the upper 400s, right? Okay, well that's what these measures of center are going to tell us. What would you expect to pay for your air conditioner if you have to go buy one? So we're going to find the mean, the median, and the mode. Now, I'm going to show you how to do it on the calculator in a minute. But in order for this to make sense to you, we're going to actually go through the formula one time. So you're going to go to the home screen on your calculator, and what we're going to do is we're going to do what this says to do. We're going to add up all these air conditioner prices. So we're going to take 500. This calculator is driving me nuts. And 840 plus 470 plus 480 sorry, it gave me an extra plus sign. I got to get rid of it. Plus 420 plus 440 plus another 440. So those add up to $3,590, $3,590. And since we looked at 1, 2, 3, 4, 5, 6, 7 air conditioners, we're going to divide that by 7. So according to this, the average price, the mean, is $512.86. Okay? Well, that's a little high. All right, that's a little bit high. So then we say, okay, well, what about if we look at the median instead of the mean? In order to find the median, what we have to do is we have to put these in order. So we would start out with the 420, and then the next number highest is 440, and there's two of them. And then the next highest one is 470. The next one is 480. And then the next one is 500. And then the highest one was that 840 Cadillac model. Okay? So once again, we've got 1, 2, 3, 4, 5, 6, 7 air conditioner prices. And the middle air conditioner price is that one.
So when we're doing the median like this, we don't, because we've got two 440s,
Mhm.
we don't leave one of those off.
No,
We just use 6 values. We use all 7.
you use all 7 values. Okay? So the median is 470. That's the middle price. And because it showed up twice, the mode is 440. Now, looking at those three numbers and realizing what you realize about that $840 air conditioner, that is a lot higher than all the rest of the air conditioners. Which one of those measures of center actually is the better of the measures? If I ask you what was the average air conditioner going to cost, would it really be correct to say it would cost $512.86? No, because there's only one air conditioner that costs more than that, and all the rest of them cost less than that. Okay? When your mean is a lot higher or a lot lower than the majority of your values, then you know you have something called an outlier. The outlier in this particular case is the 840. So if I had to keep all of those air conditioner prices and somebody asked me, what do you expect me to have to pay for my air conditioner, I would probably tell them $470. Because that makes a lot more sense. It's right in the middle of all the data values. Now, sometimes when you have outliers, it's more helpful to eliminate the outlier and then recalculate your mean, your median, and your mode. And if you do that, all we're going to do is I'm going to have these same numbers, except I'm going to leave out that 840. So when I add up the prices, without the 840, the mean is gonna be $2,750. But when I eliminate the outlier, I only have 6 data values, so I'm gonna divide this time only by 6. Ah. And that's $458.33. So if you compare the mean with the outlier and without the outlier, notice how much taking out the outlier drops the mean. So then we're going to recalculate the median. But when we recalculate the median, all we're going to do is skip the 840. So we have 6 values left, 1, 2, 3, 4, 5, 6, and the median is going to be between these two. And since it's between those two, we're going to add those two together. And divide by 2 to find out what's exactly halfway between them. So 440 plus 470 is going to be $910. And we're going to divide that by 2, which is going to give us $455 if I calculate right. Y'all check my arithmetic. So the median is $455. Now, has the median changed?
Yes.
Yes. Why did it change?
Because the outlier was limited.
Yeah, because you left off one of the numbers, so it moved to a different place. So the median, actually, if you look at it, the median kind of improved its estimation ability because 455 is pretty typical. Okay? Did the mode change? No. Notice that the mode didn't change. But the mean and the median did.
What is the purpose of finding a mode?
It can be a good measure of what's typical, of what's average.
So,
Like, for example, if you're looking at housing prices, and, you know, if I were to go to a community and most of the houses are within, you know, a few $1,000s of each other, but maybe the median value probably is a good one, but let's say that there were about 12 out of 15 houses that all cost $89,000. And then you had, you know, a house for $125,000 and one for $75,000 and one for $90,000. You know, but that mode number, because it's so populated, there's so many of it, a better guess for what you're going to pay for a house in that community would be that mode number. But I mean, if it shows up twice, it really doesn't. You know, if you got two $87,000 houses, then
that might be a coincidence.
yeah, probably is. Okay? So, what happens if you have an outlier? Well, if you have an outlier, not mode. It pulls the mean up if it's large. It pulls the mean down if it's small. Okay? So that's its effect on the mean. Its effect on the median isn't very large. It doesn't affect the median very much. Because if you notice, we wound up with 455 when it had been 470. Now, yes, the median came down, but it didn't come down that much. Okay? It came down $15. It doesn't affect the mode at all. The mode doesn't care about the outlier. If there even is a mode, because as I said, you don't necessarily always even have a mode. Okay? So at this point, I'm going to deviate to the PowerPoint for a second. And we're going to look at something called the peaks in a data set. This is called a unimodal data set because it has one peak. Remember the bars tell you how many times that number showed up. Okay? So whatever this number is for that bar right there that I've got my mouse at the top of it, that's going to be the mode because it has the highest frequency. So when it has one peak, it has one mode. Okay? This one has two peaks, one here and one here. And when you're talking about a distribution, that second shorter peak isn't necessarily the mode because the first peak is the mode, but it has two very distinct peaks. And that second one's probably there for a reason. Okay?
Is it always the first one, or if the second one is bigger?
If that were turned around, no. If that were turned around and the first one was, it was distinctly higher than the ones around it, but then the next one was way higher than that, this one would be the mode, but we would still call it a bimodal data set because bimodal just means it has two peaks. Okay? So the peaks are just looking at it in relationship to the data values that are fairly close to it. Okay? The top of the mountain, so to speak. It's also possible that a distribution has no peaks. And what that distribution would look like if it has no peaks that has no peaks at all, then it might look like this. Now, granted, there are some higher and lower places, but, nowhere on here are any of them way higher or way lower than the ones around them. So this would correspond to a histogram that maybe looks like this. So you see all the bars of that histogram. While they're not all exactly the same height, there's not a real huge difference in any of their heights.
So if you had an outlier in that data set, and this one without a mode, would that end up being your peak or your mode? I mean, if you had like, say in the middle of that data set, you had something that was twice as,
You mean one that might look like this?
yes, and then everything else settles back into its normal pattern. So then that become your,
That's your mode. But notice because it's showing up so many times, that isn't gonna make it an outlier. Even though because it's not necessarily a lot more than the ones next to it. It's just that it's showing up more often. It's the frequency. Okay? Now, as far as an outlier in a data set, we're gonna look a little bit more back at the air conditioner data set in a minute. You will be able to see the outlier in a data set when you make the histogram for it. So if we were to go back to the air conditioner problem that we have here, this is kind of what our distribution would look like. I have 1, 2, 3, 4, 5 that are in the 400s. So 1, 2, 3, 4, 5. I have one that's in the 500s. I don't have any 600s. I don't have any 700s. But I do have one that's in the 800s. What do you notice about where the outlier is? Way off from the others, right?
Just because it's a peak doesn't make it an outlier.
Yeah, but in fact, here's the peak, and it's not an outlier. It's actually the most common one. Okay? The outlier is the one that falls way higher or way lower than all the rest of the data banks. This one falls quite a bit higher. And you would have to be sure and include the 600s and the 700s, or it wouldn't be so obvious to you that that's an outlier. So looking at this one, how many peaks would you expect if I did a histogram of all the women at a college?
modal or unimodal.
Yeah, it would be unimodal. It would have a peak kind of in the middle, okay? What about the heights of all the students at a college? Male and female. It would probably be bimodal because on average, not, here again, you know, we talk about averages, it doesn't mean it is always true. But on the average, men tend to be a few inches taller than women. So we would probably have a peak over the normal, what we'll think of as the normal or the usual height for a woman, and then there will be another peak over the usual height for a man. Okay? Because those two usual heights would be different. What about the number of people with a particular last digit, say 9, in their social security number? Do you think you'd see a peak? Probably not, right? I don't know if you know this or not, but the numbers in your social security number actually identify something about where you were when you applied for that social security card. For example, is there anybody here from Virginia that got their social security card in Virginia? What's the first 3 digits? Just the first 3. 231. Okay. Almost all Virginia social security numbers are 231, 277. They're 2 somethings. In Tennessee, it's 409, 410, 411, And it might be 412 now. 413, okay. Because as time goes on, we have more and more people. They don't retire a social security number. I'm pretty sure one of these days they're gonna figure out they messed up that system because they don't retire social security numbers, which means eventually they're gonna run out of numbers. But those first 3 digits tell you what state you were in when you got your social security card. Okay? The second 2 digits say something about, I think, the county. I'm not sure. The second 2 digits have something special too, that they denote about you, but I don't know that it's state. It's something else. But the last 4 digits of your social security number are totally random. There's no pattern, no way that they come out, you know, they don't just give the next person one. They have to keep up with it. Okay, so your last 4 digits are unique to you, which is one of the reasons that you need to be careful who you let know even those last 4 digits of your social security number. Because if they know the last 4 of your social, and they know the other 2 pieces of information about you, they can figure out what your social security number is. Okay, so be careful about using those last 4 digits. But if we were going to talk about that whole data set of the last digit of everybody's social security number, what's it going to look like? Is it going to have a P? I mean, you know, some of the numbers are going to show up a few more times than the others, but not a whole lot. So it's going to look kind of like that distribution that I drew there, that just kind of like, the top's not perfectly level, but it's pretty steady. It goes up and down, but only by a little bit. Okay? This is called a symmetric distribution. Things that have symmetry have a center line that if you could fold them along that center line, their right and left half are mirror images of each other. For example, if you, this doesn't work perfectly, this is because nature is not perfect. If you look in your mirror and you draw a line down through the middle of your nose, the right and the left half of your face should be roughly mirror images of each other. Your face should be symmetric, okay? Most people's faces are not completely symmetric, but this piece of paper is symmetric because if I fold this piece of paper in half, there's its right half and its left half, and they look exactly the same. Okay? If I cut a heart out of this piece of paper, it's still symmetric because this half looks just like this half. Okay? So that's what symmetry means. This histogram is symmetric because these bars are pretty much the same as these bars. Now, it doesn't mean it has to be perfect. This bar could be a little taller than this one. This bar could be a little taller than that. Wouldn't matter. It's still symmetric because they are roughly the same. Does not have to be perfect. We talk about this distribution and we say that it is left skewed. When you talk about skew, what you need to remember is that the direction of the skew, left or right, is where does it trail off. If it starts low and winds up high, that's left. Low to high is left. High to low is right. And that's what this next one looks like. That's right skewed. So the thing to get your brain trained on is that skew does not follow the mode. Skew follows the outlier, if there is one. Okay? You name the skew right or left depending on where the least frequent values are, not the most frequent. It's not the peak, it's the valley. And I want to make this a little bit, So these are shapes of distributions, and notice that if you have a symmetric distribution, your mode is in the middle. Your mean is in the middle, and your median is in the middle. They're all the same place. Now think back to when we looked at the outliers. Does this data set seem to have outliers? Yeah. Outliers are the lower values. What happened to the mean? Remember which one it influenced? Did it change the mean? It drove it down. Didn't change the mode. Didn't change the median, but it drove the mean down toward it. And the same thing if it's right skewed. Right skewed is where you have outliers at the high values, and again, it pulls the mean away from the mode and the median. So the mode's always the peak, the mean gets pulled toward the outliers, and the median is roughly the middle. Okay? Now the last thing we haven't talked about yet here is something about variation. We talked about measures of center, but there's also measures of variability. For example, here, you've got a data set with a peak, but most of the data values are within a very small window, a very small range. Here, they're spread out a little bit more. It's almost as if I took this one and put my hand on top of it and squashed it a little bit. And squashing it kind of scooches out. If I kept my hand on top of it, squashed it some more and start looking like this, that means there's a lot of variability because there's a lot of smaller numbers and a lot of larger numbers, but there's still a peak, okay? The example says, how would you expect the variation to differ between the times in the Olympic marathon and the times in the New York marathon? What do you think? You think they'd be very different? Why?
Yeah, Olympic marathon, I think it can, because only based on people that are in the Olympics, it'd be a long variation.
Yeah, it would be, the Olympic variations would be tighter, because these are people that train intensively, and they only compete every 4 years, so they train intensively for 4 years. And they're all, now, I mean, you know, if you've watched the Olympics, all of your top medalists are really, really close to each other the rest of the time. Now, in the New York Marathon, who runs the New York Marathon? Anybody that wants to. Now, are there some people that train for that marathon? Yeah, and they're gonna have shorter times. If I were to run that marathon, which I wouldn't finish it, but, you know, if I were to try to run that marathon, you think I'm gonna come anywhere close to those runners that have trained for it all year? Probably not. I mean, I got a long time. You know, they like to talk about a 6-minute mile, how about a 6-hour mile? So yeah, there would be a lot of variation between those two, okay? The Olympic would be small variability, New York, a lot broader. This might be the Olympics, this might be the New York, okay? I didn't mean to go quite that far, I don't think. Okay. One measure of variation is the measure of variation called standard deviation. Before I go to this particular slide, for a minute, I want to go back to the air conditioners again, one more time. So back to the air conditioners. Now let's get the calculator. Press your stat button. Go to your data. We don't care about list 2 right now. At all. We could care less. We're only going to use list 1. Now, if you want to erase what's in list 2, you can. You don't have to. I want to put those air conditioners in list 1, those prices. So the first one was $500. The second one was $840. The third one is $470. The fifth one is $480. The sixth one is $420. Then we have $440 and $440. So there's 1, 2, 3, 4, 5, 6, 7 air conditioners, okay? Once you've got those air conditioner prices in list 1, I want you to press the stat button again, and I want you to go over to the middle menu, the one that's called the calculate menu. Only this time we're going to do the one that's at the top, okay? We're going to do the one that's at the top, 1 bar stats. Hit enter. And because our air conditioners are in list 1, then all you have to do at that point is hit enter. Now, if it was in any other list, if we had put them in list 3 or list 4, then we would have to tell it specifically which list. But if you don't tell it anything, it assumes that it's list 1. So I'm going to hit enter. Now, the only thing on this screen you need to worry about, there's the mean. $512, and if you round it, 86 cents. This one doesn't tell you anything, that tells you nothing. This number is a measure of variation. It's called the standard deviation. We did not calculate it by hand. I'm not going to calculate it by hand. There's no need for anybody to ever calculate it by hand because the formula is long and ugly. Okay? So there's your standard deviation. And if you think about what we saw on those air conditioner prices, what's causing that standard deviation to be $146, which is what I would consider to be pretty high, is that $840 air conditioner. Okay? So the only 2 things you care about here are this number and that one.
I'm sorry, I can't see. The 146.
The 146.83. What that essentially says, you don't have to remember this, but this will give you kind of a feel for what this is the average air conditioner costs around $512.86, give or take $146.83. They vary by about almost $150. Now, if you look at those air conditioner prices, they don't vary by that much. The only thing that's causing that huge variation is that $840 because it's $300 at least higher than most of them. $400 higher than quite a few of them.
And what's that number called?
It's called standard deviation. Okay? Standard deviation. Now, if you notice here, there's an arrow that points down. We're going to look at that, and I want you to make a note of what you see, but don't worry too much about calculating it, because when you calculate one variable statistics, you're going to get this, and that's going to be the last lesson. That's it for today. What this tells you is that the cheapest air conditioner was $420. The most expensive air conditioner was $840. And the middle air conditioner, when you put them in rank order, the median in other words, was $470. Notice it did not tell you what the mode was. You gotta figure that out for yourself. But that's just a count, okay?
What's Q1?
Q1 is the median of the lowest half of the air conditioners. That's the best way I can explain it until we get to the
Okay.
other
So,
practice.
it's
And then
for
the,
the deterrent, then it's the same as the mode, right?
yeah,
Okay.
it happened to be this time, but it isn't always gonna be, okay? But basically, Q1 and Q3 tell you that 50%, because those are called quartiles, they divide the data up into 4 equal sets. And it's telling you that 50% of those air conditioners cost between $440 and $500. Which kind of helps you think about what a typical air conditioner is going to cost. Now, what happens if we drop out the outlier? Well, we can just go back to stat, hit enter, go find that $840 air conditioner and delete it. And then go back to stat and calculate one variable statistics again, and notice what changed. Your mean is now dropped down to the second one we found, $458.33. But look what else changed. What's the standard deviation now?
About $30.
Yeah, that's right around $30. Does that $30 look a little more reasonable when you look at the majority of those air conditioners? Yeah, the only one that's really very far from the others is the $500 one, and it's only $20.
It won't let me look this way.
Oh, you have to get it out. You have to redo it. Yeah. Get it? So notice it dropped down your variability a lot by taking out that outlier. And if you scroll on down and look at what we call the 5-number summary, it says your cheapest air conditioner was $420, your highest air conditioner was $500, the median was $455, and all of that is exactly what we calculated over here. It doesn't tell us the mode, but the mode didn't change. But it tells us 50% of these air conditioners are going to cost between $440 and $480. Okay? Quartiles, think of the word quarter. There's 4 quarters in a dollar. So what those quartiles do is they break the data up into little 25% each chunks. So if we look at this, we have a set of data that is the waiting times at Big Bank. And what we want to calculate is the 5-number summary, which is the low score, the first quartile, which is the median of the lower half, the middle quartile, it's also called the second quartile, by the way, it could be labeled as Q2, is the median of the data set. The upper quartile is the median of the upper half of the data set, and then you have the high score. So we're going to calculate that for those numbers, and all we have to do that is go to our calculator, hit stat, enter to edit, get where we can, all right. You behave. Okay, I think we can see it all right there. So we've got 4.1. 5.2, 5.6, 6.2, 6.7, 7.2, 7.7, 7.7, 8.5, 9.3, and 11. And then to make sure that I didn't miss enter any of those, I'm gonna scroll back through these with the arrows. Okay, and they're all right. So now that you've made sure all of your data is in the right place, what you do next is you hit your stat button again. You right arrow to the calculate menu, and you choose one variable statistics. Just press enter, and then enter again. So stat, right arrow to calculate. We're choosing one variable statistics, so we just hit enter. And the data's in list 1, so it'll default and just say enter again. There's your descriptive statistics. The mean is 7.2, standard deviation is 1.96. That means typically we expect most customers to wait about 7.2 minutes, but that can vary by almost 2 minutes. But what we're interested in is the 5-number summary. So the minimum value is 4.1. Q1 is 5.6. The median is 7.2. Q3 is 8.5. And the maximum is 11. Now, just looking at those numbers, it's still, human brains don't necessarily analyze numbers just laying on a page. But you can make something called a box and whisker plot from these numbers that'll let you visualize how this data is spread out. So what we're going to do now is we're going to do a box and whisker plot. And we're going to do it on the calculator. Okay, here we go. And I'm going to do this with you rather than try to just show you there. We're going to do it on the calculator, but I'm going to help you sketch one by hand first. So here we've got the 5-number summary for those waiting times. And we're going to draw a picture based on just those 5 numbers. So the first thing you do is you need to have a number line that goes from a little less than the smallest one to a little more than the biggest one. And since I've got them on here, then I'm going to just pop that over like that. So you can work with me here. So now it says my minimum time is 4.1. Well, this is 4 and this is 5, so 4.1 is probably right about here. So you put a big dot or a little square or something. You put a marker where that is. Your first quartile is 5.6, so that's a little better than halfway between 5 and 6. So you put a mark there. Your median is 7.2. This is 7, so 7.2 would be maybe about here. Your third quartile is 8.5. And your maximum is 11. okay? Now, this is how you turn this into what's called a box and whisker plot. Draw a line through Q1. And draw another line through the middle of Q3. Connect those lines up to make a box. And then connect Q3 to the maximum and Q1 to the minimum. And then draw another line through the median. And what I want you to understand is this is 25% of your data. This is also 25% of your data. Notice that they are not even. This one is 25% of your data. And then this, even though there's a lot broader range, this is also 25% of your data. So your maximum waiting time, if you look, is quite a bit higher than your other waiting times. It might be an outlier, but probably not. I mean, it's not that much more than 8.5 minutes. Okay? But it does tell you that your data set is skewed to the right. It's skewed to the right because the right whisker is longer than the left one. Okay? Now you can make that same graph on your calculator. You don't always have to draw those by hand, but you have to admit that's pretty easy to draw by hand. On your calculator, go back to your stat plots, second y equals, choose plot 1, it's already turned on, go down one arrow, and the one we want is on the middle of the bottom row. You see where I am? Press enter when you get to that one. Notice that it turned off the scatter plot and it turned on the box plot. Everything else is already set up, so you don't need to do anything else. Now yours, let me see what y'all's screen looks like, see if it's different. Keep scrolling, keep going on. Okay, and then press enter, and then after that, just arrow all the way to the bottom and hit enter. Okay? And now we want to do just exactly like we did to make the scatter plot. We're going to go zoom 9, just like we did before. And there's your box plot. Everybody see your box plot? Oh, yours has got the extra.
have no idea what that other stuff was. Okay, now, the other problem that's on here, I've already talked to you about the standard deviation and the range. The range is basically the high and the low, and the range doesn't always tell you much because it only looks at those two numbers. Standard deviation looks at all the numbers. So I've already showed you how to calculate standard deviation. I've recorded this whole problem for you on Shobi. It's all there. It walks you through every single one of these. So be sure and look at that. We could put the test off until Monday, but that means we'd have a test on Monday and Wednesday next week, which is probably not a good idea. Okay?
What? Is there like two reviews that we're supposed to do, or just the one?
There's only the one to do before the test is coming up. That's why I'm still gonna do the test on Wednesday. If anybody has any questions whatsoever about the review, I'm gonna go ahead and put the answers up to the review. Okay? I'm gonna go ahead and put them up. I'm gonna trust you to do the work. The answers are gonna be there for you to check yourself, so if you get one of them wrong or you don't understand, ask questions.
Yourself.
No, you cheat yourself if you cheat, so that's why I don't worry about it. So I'm gonna actually, right now, before I close out, I'm gonna put the answers up for the test review.